In this section, we're going to be looking at perpendicular and angle bisectors. To start off with, we're going to look at a term, equidistant. A point is equidistant from two objects if it is the same distance from the object. Now we're going to look at a theorem, Theorem 5.2, perpendicular bisector theorem. The theorem states if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So here we can see that point P is on the perpendicular bisector, and this perpendicular bisector is perpendicular to line AB, and it bisects AB into two equal parts, so MA equals MB, and because of this, PA is congruent to PB. Now we're going to look at another theorem, Theorem 5.3, converse of the perpendicular bisector theorem. Basically, this is working the same theorem except backwards. It states if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So here you can see that we have a triangle, PAB, and PA equals PB. Because they equal each other, if we were to draw a perpendicular bisector down point P, and make it perpendicular to line AB, we would create two equal segments on line AB. So MA would be equal to MB. Now we're going to look at an example of using the perpendicular bisector theorem. Here in our diagram, we can see that line BD is the perpendicular bisector of line AC. So B is equidistant from A and C. So we can go ahead and use the perpendicular bisector theorem to say that BA equals BC. And then we can go ahead and substitute the values that they've given us. So BA is going to equal 4x, and then BC is going to equal 6x minus 10. Now what we want to do is go ahead and solve for x. So start off by subtracting 6x from both sides. When we subtract 6x from both sides, we're left with negative 2x equals negative 10. Then you want to isolate the x, so divide both sides by negative 2. When we divide the left side by negative 2, we get x. When we divide the right side by negative 2, we get 5. So x equals 5. Now, in order to find AB, you want to go ahead and plug in the value of 5 back in for x. And AB equals 4x. So AB is going to equal 4 times 5, which equals 20. Now we're going to look at the next theorem, Theorem 5.4, the angle bisector theorem. The theorem states if a point is on the bisector of an angle, then the point equidistant from the side of the angle. So here you can see that if bisector QS bisects angle PQR, line SP is perpendicular to QP, and SR is perpendicular to QR, then we can say that SP is equal to SR, as indicated by the red line. Now we're going to look at another theorem, Theorem 5.5, the converse of the angle bisector theorem, which is basically working the theorem backwards. It states if a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. So here in this diagram we can see that we have a point, it's on the interior of the angle, and SP is perpendicular to QP, and SR is also perpendicular to QR. And based on the red line indications, SP equals SR, and because of this information we can conclude that ray QS bisects angle PQR. Now we're going to look at an example using the angle bisector theorem. Based on the diagram, we know that ray NR bisects angle LNQ. Line RM is perpendicular to line NL. Line RP is perpendicular to line NQ. And what we need to find is the length of RM. So using the angle bisector theorem, we can say that RM is equal to RP. Now we can go ahead and substitute in the values that we have. So RM equals 7x, and RP equals 2x plus 25. We want to go ahead and solve for x now, so start off by subtracting 2x from both sides. This leaves us with 5x equals 25. Then you want to isolate the x, so you want to divide both sides by 5. This leaves us with x equals 5. So now you want to go ahead and plug in the value of x back into the Rm equation. So Rm equals 7x. So 7 times 5 is going to equal 35, and that's going to be the length of Rm.